Okay, so here's the thing that most AI research scientists won't tell you. AI is not intelligent. Artificial intelligence is an oxymoron. Something's either intelligent or it's not. You can't have an artificial form of it. So in the field of computer science, I'm going to get a little technical here, but the most fundamental theorem in all of computer science is that there's a hierarchy of computing power. So there's certain languages called context-free languages, which have a certain amount of power. You can represent things, for example, expressions like in arithmetic expressions with parentheses and multiplication, addition operators. And you can build a language that recognizes a complete arithmetic expression. And that has a certain amount of computing power. It can't recognize certain other types of patterns. And there's a more powerful language called regular expressions that can recognize those. And that allows you to do wildcards like 0 or more of this pattern, 1 or more of this pattern, which context-free grammars can't do. Then above that, then you have something, and there's other things, but these are the basics. So the highest level of computing that we know of is Turing equivalence. So Alan Turing was a famous mathematician, really the founder of computer science, and he came to realize that, well, his work plus the work of another researcher called von Neumann realized that there's one type of computing that we can know how to build, like the most powerful type. There's these less powerful types, but the most powerful type we know how to build, everything that has these basic capabilities is exactly equivalent to everything else that has these capabilities. So, the phone in my pocket is exactly equivalent to that laptop, exactly equivalent to this computer, exactly equivalent to the most powerful supercomputer in the world. Anything my phone can do, the most powerful supercomputer in the world can do. Anything that supercomputer can do, my phone can do, but it might take a lot longer, but it can't do more than that supercomputer can do, right? So Turing equivalence is a very powerful concept because it means that all computation, and I mean this, again, the most powerful form of computation, all computation is equivalent to all other computation. This is the deepest result in computer science. Everything in computer science comes from this one thing. So what is that? Well, I mean, there's different ways to think about Turing equivalence. So there was something called a Turing machine, which had a paper tape, and it had a little head on it that could read a symbol on the tape, and then it could wind the tape to the left or right, and it could write a symbol, which is basically memory, right? And so the basic operations would be, left, right, read or write, and then an if statement. And then there's a loop as well. So that's one way to look at it. Another way is called the structured programming theorem, where you have, I think, 3 different principles. So one, if you want something to be Turing equivalent, it has to be able to execute one thing after another. Secondly, you have to have conditional logic. So if this is true, then do this, otherwise do this. And the third thing you have to do is you have to have looping, right? So you can keep doing something until a condition is true. So if you have those 3 things, then every system that can do those 3 things is equivalent to every other system that can do those 3 things. So if you wondered how computers worked before, now you know. Like, this is all that they have to do. It's very, very simple. Now, intelligence, this is the thing that you won't hear other AI researchers telling you. Intelligence is fundamentally more powerful than this, in my opinion. And so one of these tools, which is not up here, but there's something called GitHub Copilot, which is a large language model for programmers. So basically, they've ingested all of this source code from all the repositories, millions of repositories on GitHub. They've learned all these patterns of both the syntactic structure of a program and the logical structure of what the program is trying to do, and the comments. They've read all the comments and tried to match the comments with what the code is doing. And they built this incredible model where, as you're writing code, it predicts what you're going to write next. And I would say probably 20% of the time, the predictions are absolute garbage. And 50% of the time, what it spits out is useful, it's pretty plausible. You don't really have to change much. And the remaining sort of, whatever it is, 30% of the time, I'll be programming, and the prediction that comes out is so astoundingly good that I literally stand up from my computer in shock. I'm like, I have this like existential crisis, and I have to walk away from the computer for a while because I'm like, how did it figure this out? Like, I don't understand. Like, a really good programmer could figure this out, but I don't understand how this machine could figure this out. Now, is that intelligence? It sure feels like it. But we humans have this innate tendency, that's okay, we have this innate tendency to impute intelligence to inanimate objects. And if I had some slides, I would show you this. There's this little video of this. There's a boiler, like a water heater, sitting out on the street. And it's got two big bell-shaped things on it, which kind of look like eyes. And there's a box that looks like a mouth. And this little girl walks up to this boiler, and she hugs it, and she's like, "Hello, Mr. Robot. I love you, Mr. Robot." It's really cute. But the point is, since we're young, we see things with faces, we see things that have human-like behavior, and we assume that they're intelligent. This is something we do naturally. My favorite word in the English language is pareidolia, P-A-R-E-I, pareidolia, which is when you look up at the clouds and you see rabbits or whatever. Like we have, our brain is a pattern matching machine, right? So we look at things, we see patterns, and then we make big assumptions about what those patterns mean. So we do this with intelligence all the time. And we have a very fundamental flaw in our logical ability, because we've never evolutionarily had to figure this out before. But we're not able to look at a problem and say, this is a problem that requires intelligence versus this is a problem that can be solved by logic, which is what a computer does, right? I believe there's actually a gap. So intelligence can solve everything a computer can do, because those three things I told you before, a human can also do: follow instructions in order, do something conditionally, and do something repeatedly, right? Humans can do that. So the question is intelligence a superset, a strict superset, meaning it's bigger than computation? I believe it is. Now, what is that? If you believe in a soul, maybe it's the soul. If you believe in, I think maybe even if you just don't want to go to the sort of metaphysical or religious aspect, I think you can actually think about it like this. I think there's a whole physics of intelligence that we don't understand yet. And our brain is doing something probably at the quantum level which gives us more power than a computer. Now, the reason why I say the quantum level is because the only thing in the universe that we can mathematically prove is a source of entropy, stochasticity, randomness, is the collapse of the quantum wave function. So if you have two particles that are entangled, and you can separate them to opposite sides of the universe, and you observe one of them by shooting a photon at it and bouncing it back, it will collapse into one of two states simultaneously, which violates relativity. The other particle on the other side of the universe will collapse into the same state because they were entangled. This is spooky action at a distance. This is what Einstein called it, right? So when that function collapses, we can prove mathematically you cannot predict what the outcome is. Everything else in the universe is deterministic. So if there's something, and I believe also that choice, that our freedom of choice is not an illusion. I think we're actually making choices. But if we were making choices that would violate determinacy, basically, that we're, like, if we are these kind of determinate beings, everything that we're going to do in our lives is already pre-programmed. It's going to unfold because we're basically a domino, right? And you tap the first domino and all the dominoes will fall, and we don't have any choice in the matter. That's what a lot of people that have a hardcore belief in physics believe, because if you look at the way molecules interact, I mean, there's really no randomness except at the quantum level. So if intelligence comes from a physics, I think it comes from the quantum realm. We're not doing this in these computers today. They're running AI models, right? These are not quantum computers. And even if we had a quantum computer, it doesn't necessarily mean that it would suddenly become intelligent, because there's a difference between something being necessary and sufficient, right? So I don't know if you've got anyone that's on a laptop, you can pull up, or your phone, the Wikipedia article on intelligence. There's a list of definitions in there. This is super interesting to go through. If you just look up intelligence on Wikipedia, there's an article with that title, and it gives you a list going back 200 or 300 years in history of all these different definitions of intelligence that people have given. And this list it's really interesting. It's, some of them are, an intelligent entity must receive information from its environment and make decisions about it and then take an action in its environment to affect its environment. Okay. Yes, all intelligent things do that. And there's a series of these. And with every single one of these, you can say, yes, an intelligent entity would do this. But you can't say, if something does this, it is intelligent, right? It's necessary but not sufficient. A implies B doesn't necessarily mean that B implies A. So this is the problem we have with every definition of intelligence, is that he attracts an immense amount of talent, right? So he reached out to me. So Larry Page, the founder of Google, co-founder of Google, hired Ray Kurzweil. I knew Ray Kurzweil from a summer program I was in back in 2009. And so Ray sent me an email, and he's like, hey, Larry Page just hired me. I got to hire a team. Do you want to join? I was like, I had to think about it, but I was like, okay, yeah, sure. And so I joined, and so Ray and I, for the first 6 months, what I did was I met with product managers all over Google and asked them if you could have, and this is before all this latest AI stuff, right? So I said, if you could have AI features in your products, what would you have? Like blue skies, no limits. What AI capabilities would you put into your products? So I made this long list of all these like dreams that all these product managers had, and went back to the drawing board, and I sort of looked really closely at these, and I boiled it all down to capabilities, and then figured out from capabilities what problems in AI we needed to solve, and then from there, after 6 months of doing this, I went out and I hired 30 engineers, and we founded a team. And so we started building these things, and some of the, if you're using the Gmail app on Android, the predictive text thing that came out of the team that I started. So I didn't work on it personally, but after I left, I made that. So you probably use that. You see words popping up, and you can like tap on them or swipe or whatever. And so anyway, so Ray, I had a lot of conversations with Ray during this time, and he gave a lot of talks. Like this guy is really, really famous. People love listening to him. And he will always say, well, you know, if you look at the curve of Moore's law, right, which is this exponential curve that Gordon Moore, who was one of the early engineers at Intel, he showed that if you show the density of transistors on a piece of silicon on a chart over time, that the density increases as an exponential curve. So if you plot it on a semi-log plot, then it's a straight line. Or plot it on a log-log plot, it's a straight line. So he showed that basically we're following this, this exponential curve of technology development. Now, that's density of transistors, but that translates pretty much into computing speed, because if you can double the number of transistors, you can do twice as much work in parallel within the same space, same area of chip. So this is translated into that computers get twice as fast roughly every 18 months to 2 years. And that's been lockstep. And you can even go backwards before transistors to vacuum tubes. And some people have even plotted all the way back to microorganisms evolving out of the primordial soup and like showing their computational capacity or whatever. Like this curve is like irrefutable. Like it just keeps going and going. And there's been a lot of prediction about the end of Moore's law, because we're trying to do things now that require so many transistors. I mean, the new Apple chips are like 50 billion transistors, which is absurd. But anyway, so Ray's claims have always been, once we can produce a chip that has as many transistors in it as we have neurons in our human brain, with the same switching throughput, the switching capacity that these transistors have, then we will have a computer that is as intelligent as a human brain. And I would always call him out and say, but how do we write the software? And he's like, oh, I trust that we'll get there. We'll figure out the software by the time we get there. And so he's totally kicking the can down the road. The fact is, you can't just assemble a bunch of transistors and then say, okay, this is going to spontaneously become intelligent because it's got enough transistors in it, so it's got as many transistors as the human brain. There's a lot of reasons for that. Number one, neurons are not transistors. If you were to look at a neuron, if you could see all of the atoms and molecules in a neuron, it's this massive, extremely complex biomolecular machine. There's so many processes going on in it that are regulating and self-regulating, auto-regulating, and there's basic things you can, like you send up pulses with a certain speed, and then you reach above a threshold, and it will send a pulse on. There's basic behaviors. But how are memories stored? We still don't really know. I mean, these molecules could be storing memories in some custom RNA molecule format that we haven't discovered yet, or something along those lines, right? So we just don't know. But it's certainly not a transistor. So this is the first fatal flaw in this assumption, that if we just build enough transistors, we'll be at the level of a brain, because what if we need 1 billion transistors for one neuron, right? Then we're orders of magnitude away from even achieving that. So, but the second thing is, how do we write that software? And we don't know. Nobody knows. And it comes back to what I said earlier. It's because we can't define intelligence. Like, we don't know what intelligence is. Try and define it yourself, because if you figure it out, you'll be world famous, I tell you. Like, nobody knows what intelligence is. When we have a sense of it, yeah?
So say you have this chip or whatever that has the same computing power as a brain, and you give it like tell it, say, like, act as much as a human like you can, how would you be able to tell the difference? It goes on this whole path of, like sequential actions, acting like a human. We've like kind of pushed the first domino, and then how would you be able to tell?
Such a great question. Okay, so, oh, is this the camera that it's recording, by the way?
It's up there.
Oh, it's up there. Okay, I was like, oh, should I be like, okay. So it's a great question. And so there's the Turing test, which is the most famous test of intelligence, and there's something called the Chinese room experiment. So the Turing test, so people have asked this question for a long time. The best answer we have, which is a horrible answer, is you put the AI in one room and you put a human in another room, and you only allow somebody to communicate with them over text messaging, basically. And so a person, an evaluator, can send a message to either room, and either the AI or the human responds. And then the evaluator's job is to determine which is the AI and which is the human, right? So let's say the AI is really good and it's able to act just like a human, then I guess on average the evaluator would make a mistake 50% of the time. Now there's problems with this, because if AI becomes more intelligent than humans, it will be easy to distinguish it, because it's going to give better responses than a human could give, right? So, if you asked it to recite something in ancient Sumerian, the AI could probably do it, given all of the information that's out there about ancient Sumerian, and the human probably couldn't, right? So you could ask it questions like that, and be like, oh, okay, I know which one the AI is, because this is definitely a computer. So that's the first problem. But the second problem, this is like deep. Like, if the Turing test is a test of the deceivability of the evaluator, not the intelligence of the observed. Right? It's how well can you trick that guy. It doesn't test anything about the intelligence of what you're observing. And so this is the fundamental problem. There was a story like 15 years ago that some like Swedish scientists or something had cracked the Turing test, that they had created this AI that deceived a human into believing it was human something like 30% of the time. And they claimed they had to dumb down the model because it would have been easy to detect that it was an AI. So they had to make it act like a so they kind of gave it this whole persona front that it was a 13-year-old Swedish boy. So if it said stupid things, you could kind of anticipate that that's what you'd expect from a 13-year-old, right? So that's how they kind of got around that. They didn't solve intelligence, obviously, because here we are still today, and nothing came from that. But this is the fundamental problem with the Turing test. Now the other thing is the Chinese room experiment, and this is more of a thought experiment. It doesn't test intelligence per se, but it gets to the nature of what intelligence is. So you have a person sitting in a room, and you pass words in through one window in a language that person doesn't speak. They have a huge dictionary in front of them with all the rules of translation and all the instructions of how to look up words. So let's say it's Mandarin. This is why it's called the Chinese room experiment. So somebody comes in Mandarin, and this person looks at the characters and matches them with characters in the dictionary. They find the word, and then they look up the rules of grammar, and then they're able to translate it by just following rules into English. So they put out the translation out the second window. So they've just achieved something that requires intelligence, maybe, but they did it without understanding what they were doing. So is that intelligence? Because, is it or is it not? I mean, I think it's probably not, because they're doing something mechanistically. This is the Turing equivalence level. They're running a program, right? I don't think there's any intelligence because there's no understanding. So intelligence and understanding go together. And I don't think it's possible to say that AI today has any understanding at all. That said, I should offer a caveat here, because even if AI is not intelligent, it doesn't mean it's not useful. Like, we're doing insanely amazing things with AI today, right? So you got to distinguish between what's useful and what's intelligent. And maybe whether it's intelligent or not is just, maybe it doesn't even matter if we're getting a lot of utility out of it. But I think it does matter if you care at all about kind of the philosophy of what's going on here. And, also because it helps us to understand ourselves. If we can really get at what intelligence is, we will understand ourselves better. And I think that's a very important thing to do from just a humanistic point of view. So, so back to the GitHub Copilot thing. So I'd had this experience where I was writing code and it was giving me these ludicrously good predictions that were based on certain constraints from other files in the project that it had inferred something about the logical structure and it had inferred what I was trying to do. It wrote the comment for me stating my intent. It had conditions checking for corner cases, like all this stuff. I'm just like, this is unbelievable. And when I had this kind of existential crisis, I'm standing up. I'm just like, I give up. Like this is too good. This shouldn't be happening. I had this moment where I realized this is not intelligent, but it feels intelligent. And so I think what's going on is that logic, the application of logic, doesn't require intelligence. I mean, this presupposes that my assumption that intelligence is doing more than computation is true, and I don't have a way to prove that yet. But assuming that is true, that means that logic itself falls in the realm of computation, not the realm of intelligence. But that logic can be so intricate that it seems intelligent, right? So then I had this other epiphany, and I realized, well, if logic is not intelligence, then what is? And if you step back and kind of look at humanity, once you get out of your head, your heart kicks in, right? And so something about emotions is directly tied with intelligence. Something about the consciousness that we experience is a fundamental attribute of intelligence. So there's a term, another word that I love, which you probably may have never heard before. I didn't until I got into AI. There's a term called qualia, which is, they say it's this experience of like rubbing your fingers together. Like, what does that feel like? You know, if you're trying to describe to somebody who didn't have hands or whatever, like, what does that feel like? How would they understand what that sensation was? Another analogy I've heard is if you were trying to describe to somebody who had never tasted salt before, what salt tasted like. How would you describe it? I mean, you'd say, well, it's salty, right? You can't describe it except in the terms of the experience that you've had, and they can't understand it except by experiencing it. So something about consciousness is able to process these qualia experiences and turn it into a subjective thing that has meaning. I mean, you know, meaning is something outside of computation. I'm convinced of that. Understanding is something outside of computation. So I mean, we're getting kind of metaphysical now, but like, I think there's something a lot bigger than what's going on here, you know, with AI, even though it's super useful, right? So I just want to make that distinction. Okay, I'm going to pause because I dumped a lot of heavy stuff on you. So feel free to ask questions, and we'll just go from here. Go ahead.
As far as like quantum computers go, and the non-binary outputs that they produce,
yeah.
Do you think that could be something that could replicate emotion or experience it?
So that's a great question. So I mentioned before that I think quantum effects are required for intelligence, but the quantum computers may not give us what we need. So the reason why I say that is because so quantum computers, the way they work is basically if you have, who's a computer scientist in here? Okay, we got a couple. Okay, so let's say, a really fundamental problem in computer science is something called the Hamilton cycle problem. So you've got a bunch of cities connected by roads, and you have to visit each city exactly once. Once you've gone through it, you can't come back to it. And the question is, given a certain map with a certain set of roads, can you start in a city, go through every other city, and get back to that city without crossing twice, like going through the city twice, right? And that problem, as far as we know, requires an exponential amount of compute relative to the number of cities that you have. So if you double the size of your map, double the number of cities, then it might take a million times longer. If you quadruple it, it might take 1 trillion times longer, right? It scales at this like intractable rate.
Is that similar to the traveling salesman?
Yes, it's very closely related to that. So the traveling salesman problem is similar, but the roads have weights on it, or basically lengths. You can measure the length of the road, and you want to travel around all these cities in the minimum time or something like that. But it's the same type of problem. And that also, so these are called NP-complete problems. NP is non-deterministic polynomial. Non-determinism is what quantum computers do. So the theory is if you had a quantum computer, which is not deterministic, meaning it can do multiple things at the same time, basically, then you could take this problem, phrase it in terms of basic operations in a quantum computer, and search this whole exponential space in parallel in one step. This is why they're so powerful in theory. Now, there's some caveats to that. You have to be able to, if there really has to only be one solution. If you've got multiple solutions, you can't really phrase it. So you might have to remove roads until there are no solutions, and then put back the last one, and now you've got only one solution, and go from there. You know, there's tweaks to it, but basically, you're expressing a problem in a non-deterministic space, which again means that you can be doing multiple things at the same time, potentially an infinite number of things. And then you have it collapse down through the collapse of the quantum wave function to one solution. Now, I mentioned before the three fundamental things of computing, right? The sequence, conditional statements, and looping. Quantum computers also have a set of fundamental operations, and I don't think they even satisfy those three things. Because basically, you're setting up a mathematical equation basically to solve that has one solution, and you're just collapsing it down to that one solution or zero solutions. So I don't think they're even as powerful as a Turing machine. There's a website called the Quantum Zoo, which you can look up. It's got every quantum algorithm that's ever been discovered. And in 50 years, or let's see, how many years? 35 years of working on quantum computing, we've discovered 35 algorithms. And these algorithms, I mean, compared to the countless, limitless numbers of algorithms that we can create for traditional computers. The reason for that is because it's very, very difficult to phrase a mathematical problem in terms of quantum operations that will solve the thing you're looking at. The types of things that you could do on a quantum computer faster than on a traditional computer involve things like the Hamilton cycle problem, traveling salesman problem. There's something called Grover's algorithm, which searches databases, but that one's not particularly useful because it doesn't reduce the time from exponential down to polynomial. It reduces it from linear down to square root n, which is a win, but you really want to run like something that gets you just a little bit of savings on like a $100 billion computer? Probably not. So some of these algorithms are not even that useful. The ones that are useful could, in theory, probably solve certain forms of cryptography, like elliptic curve cryptography, faster, potentially destroying that whole field of cryptography. There are other algorithms that are quantum proof, but there's really not much we can do with quantum computers. And again, there's nothing that links quantum computers to intelligence, because we don't even know what intelligence is, right? So these operations we can do with quantum computers don't necessarily underpin intelligence. They may, but we don't know because we don't even know what intelligence is. So, I mean, it's a great question, but I don't think that's the route to getting to intelligence. I think we need to understand a lot more fundamentally about the physics about quantum physics and about intelligence before we can start figuring out how to build that, the quantum part. So, yeah.
Okay, so I thought this idea of qualia, or kind of like, I don't know how to even paraphrase that.
That's the problem with qualia. You don't know how to put it into words, right?
I thought that was really interesting, and also the idea of understanding versus intelligence kind of blew my mind a little bit.
Mm-hmm.
In our world, with like the introduction of VR, like I imagine, I mean these guys would know better than me, but the future of probably like a lot of business and communication is all going to be this virtual world pretty
Mm-hmm.
soon. And then with the introduction of AI and all this new technology, do you see any potential dangers or problems with the world that's increasingly less like physical and more virtual, with like talking about these things?
Massive social problems, yes. We're already in a place, I mean, you've all grown up in a day, you probably all had smartphones since you were young, I'm guessing, but, okay, one guy was shaking his head, I won't point out who. I grew up a while before smartphones were available, and I can tell you, people are way less connected today than they were before we had this hyper-connected technology, right? Before we had social media and all these apps and like instant connectivity in our phone, and like I can call my parents in New Zealand right now and they'll pick up. Like long before any of that was possible, people were more connected. So I think just the bigger picture is, yeah, there'll be more and more problems. I mean, there's this court case, or there's the police thing on the news right now about some high school where some photos were passed around of deep fake nudes of like some girls in the school that put the AI, they used AI to put their face on these bodies, whatever. So the police are trying to figure out who created these pictures. That sort of thing, it's horrible. Yeah, I see your facial expression. It's horrible. But I mean, this sort of thing will become commonplace, right? People are going to get so desensitized to it. And what's the end result of this? We're not going to believe anything we see or hear. Because, so what does it mean to live in a society where we literally can't trust our senses anymore? Because AI is so good that we can create something that's so real that it's like so we know everything is probably fake, so then we don't question things that question things that are real if they're fake also. So anytime you introduce a new technology, there's always going to be, it's always used for good and evil, right? There's always going to be good applications and bad applications. There's going to be people misusing it. Go ahead.
So speaking from like an ethics perspective, do you think the same people that are currently like pioneering AI and stuff like that and developing it, is it their responsibility as well to generate and create things that are able to identify whether it was artificially created or be able to siphon through things that have been created with AI so that you're able to combat that so we're not losing that ability to use our senses?
Yeah, that's a great question. So there's a lot of work on detecting AI-generated images, AI-edited images, and so on and so forth. Unfortunately, that's made more difficult because a lot of this generative stuff that is coming out now, it's based on what's called adversarial networks, where you have a generator and a recognizer. So the generator tries to create plausible instances of whatever you're trying to create, and it tries to trick the recognizer into thinking that it's real. And the recognizers, or distinguisher, I forget what the term is that they use, the job of the recognizer is to determine, is this real or is it fake? And so every time the recognizer is able to pick a fake, then it sends feedback back to the generator, oh, you got to do better. Like, you got to figure out more where the boundary is between what the recognizer is going to recognize as real and what it's going to recognize as fake, right? And so they go back and forth and they compete. So the generator tries to produce better and better and better fakes, and the recognizer tries to determine better and better if this is a fake, right? Because this is how all these generative models are trained now, it's going to get more and more difficult for anyone to build these things that can distinguish. Is just like how it's going to be harder for humans to distinguish if things are real or fake. I mean, you can go, do you guys know what Midjourney is? It's insane. It's unbelievable. DALL-E is another one. I like Midjourney, but Midjourney is this thing where you type in a text description of what you want, any scene, anything in it, any artistic style, cartoon, oil painting, photograph, and it will generate something that half the time is ridiculous, but the other half of the time looks exactly like what you just described. The photographic realism of that is unbelievable. Yeah, this is another, I wish I had brought my computer because I could show you some example images of this, but check out Midjourney. Unfortunately, it's not free anymore. You got to pay like $10 a month, but it's worth it just to play with it because seriously, it's going to blow your mind. So the photographic realism in that is, I mean, I think one of the first things that will be affected by this generative AI will be the modeling industry, because you can create a picture of anybody with any type of ethnicity, facial features, wearing any type of clothing, in any type of setting, posing in any type of way that you can describe, and it will just produce it. It's like that's available today. So I think some of those things will happen. Now, one thing, I didn't fully get your question, sorry, that you asked earlier, but so if there's more of that, I should probably get back to that. But I do want to offer one insight here, though, too, into specifically how generative AI will affect creativity. So a lot of artists feel really, feel like AI is kind of destroying their profession, and also, they're also angry because AI is trained off of images that are available on the web, and which is a lot of, these artists had produced images that were used to train models that now produce artwork that looks like their pictures, right? So, a lot of artists in particular are angry. This will happen for music. Music is a little further behind because I don't think there's as much focus on it right now, but I mean, we'll get there with music as well, where you can produce better music faster with AI than an artist could produce in hours and hours of work, right? So, but I think I think people are looking at this in the wrong way. If you have this sort of generative AI, if you can look at it as an idea generator, you can produce 1,000 ideas in the time it takes you to produce one if you use AI tools. Based on all those ideas, you find things you identify with, and then you make your own version of it, right? And so in that sense, I don't see either of these concerns as a problem. You know, people that don't adapt to modern technology as it comes along, they're going to get left behind. And this is a clear case of that. Like, creatives need to use these tools because it's a power tool for the human brain and for human creativity. And as long as you look at it as a power tool and use it for the good purposes, not the bad purposes, then I think you can get a lot of mileage out of AI. So, yes. Oh, this guy behind you, so let's go to him first.
Yeah, what do you think the next couple versions of GPT are going to look like? Like, what are the opportunities for LLMs going forward?
Yeah, so, I mean, these models keep getting bigger and bigger, right? I've lost track of the parameter counts, but there are hundreds of billions of parameters. Training an LLM takes 2 months on, like, basically a supercomputer today, and they're just going to get bigger. I mean, they'll get bigger, they'll get more capable, they'll be able to do more things. ChatGPT 5 is supposed to have images and text all in one model, so it's all linked together. So basically, it's Midjourney and ChatGPT merged. But also it does recognition, not just production, so you can ask it questions about a visual scene and it will answer the questions. So we'll see more integration, we'll see more modalities being linked in, there'll be audio, there'll be speech. I mean, you know, you can envision a time where you want to see, like, some politician give a speech about some topic. You just describe the points that you want them to talk on, and within 30 seconds you'll have a video of this politician giving this elaborate speech, probably almost indistinguishable from the politician actually giving the speech, right? So I think it's just going to get more integrated, and the times when generative AI produces something ridiculous, the incidence rate of that will go down over time.
Yeah, so nothing like new, it's just like better versions of what we have now. Like, do you think there's any other, like, leaps that are going to happen? Because it seems like between 1 and 2, you know,
Yeah.
there are a lot more leaps, and then now it's just like improving what we have.
It's a great question. I mean, I was wrong about when we would have language models this good. I thought it would be another 20, 30 years. You know, what I was doing at Google was working on natural language processing, natural language understanding with some of the best AI scientists in the world, and I completely was off the mark as far as when we would get there. And what we have today is pretty dang amazing. I think if we're going to see big leaps in the technology, it's going to be in reducing the model size dramatically, so you can have something like ChatGPT 5 but running on your phone, completely on your phone, trained in an hour, not 2 months, right? But that's going to require some big innovations in how the computation is done, including the mathematics that underlie all of this, as well as the engineering of how to compute things faster, right? I have some theories about how that should work, and actually some of the big founders of AI have commented repeatedly that they believe that backpropagation, which is how neural networks are trained, it has to die, because, like, the way all these models are trained is you start with your network randomly assigned weights. So neural networks basically have a node, and they have edges that connect to other nodes, and these edges have weights on them. You take the value in a node and you multiply it by the weight, and you basically pass that value on to the next node. And if you have a layer of nodes and another layer of nodes, the edges are all connected between the first layer and the second layer. That process is a matrix multiplication, which, if any of you have done linear algebra, that's a linear operation. So then you have a nonlinearity. Otherwise, if you had layer, 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 and you just kept multiplying matrices, you could collapse that all down to a single linear operation, which would not give you, would only allow you to distinguish between two clouds of points with a linear surface, like a hyperplane. So if you want a surface that can fit around the structure of your data, you have to have nonlinearities. And so you basically have the linear weights, and then you have a nonlinearity, and then the linear weights and nonlinearity. So that's how neural networks work. the way you train them is you set the weights all to random initially, and you feed in input data, and you have the output data that you expect to get out. You feed these values in, you compare the observed outputs to the expected outputs, and any difference is an error. And then you take the error and you start propagating backwards through the network to adjust the weights, you adjust the weights in a way that will minimize the error next time. And then you do it for another training example with an input and an output. And you do it again, and you keep back propagating and adjusting the weights. So that's back propagation. That's how all of this works. So the problem with back propagation is it's extremely inefficient. It's not how the human brain works. The human brain doesn't sort of back propagate errors. We have some other way of adjusting our synaptic strengths between the synaptic junctions to learn certain things. So a lot of these luminaries in AI, the early guys, Jan LeCun and all these, the big original luminaries, they say categorically backpropagation is not the long-term solution to continuing to scale these networks. Because, we're killing polar bears, melting the polar ice caps because of all the energy that's required to do all those computations. So we need a better way to do it. I think there's variations of this that are fairly simple that would solve this problem. And I want to work on that in the future. But that's the sort of thing I would see in the future as far as big leaps forward, would be completely replacing backpropagation, building much more compact models with far fewer parameters that have equal or greater power to the current models. But in terms of fundamental language capabilities, computer vision capabilities, I mean, it's anybody's guess. I don't even know how to predict that sort of thing. So, yeah. More questions? Yes?
Just us as students right now, and then in the next few years we'll be getting jobs. What do you, as like a programmer who's worked on this stuff, see as far as education, like how education will change, and then also how the workforce will change for us and then younger generations?
Yeah, that's a great question. I mean, for education, you probably either want to be a computer scientist or you don't, right? So I would say to everyone, take some computer science classes, but it's not for everyone. And it's difficult, and you may or may not use it. But programming gives you superpowers, I think, in almost any job, no matter what you're doing. There's going to be something that needs automating. And so if you have the ability to write a little program to do something for your boss where he needs a certain piece of data, like a spreadsheet ingested and certain things processed and then spat out, like if you have that ability, then you've got a superpower that your peers don't have, right? So I mean, that's just one thing. If you're not a computer scientist, just take a couple of basic programming classes so you at least know the fundamentals, and then that will serve you well. You're going to use it at some point, and it may even become a hobby, and may even become a profession for you. As far as AI, I mean, everyone's saying now that like the hottest new job is like as a prompt engineer, which I think is kind of dumb, honestly, because the fact we need prompt engineers means that these models are not good enough yet to understand what we actually want them to do, because we have to like trickily like change the words, tweak everything to get exactly the output that we want. So I think that idea of, oh, we should all be prompt engineers, that's the hottest new career, I think it's going to go away in a couple of years. Like, yeah, don't believe in that. Like, prompt engineers are just there because of deficiencies and capabilities right now. But knowing how to leverage AI for any role that you might be in will be important. There's something I needed to I had to do some marketing for something fairly recently, and I used ChatGPT to generate ads for 50 cities across the US, and each ad had to be slightly different because Craigslist has this spam detector, right? So the wording has to be different. So I just said to ChatGPT, okay, here's the parameters of what I want in this ad. This is what I want you to emphasize. Generate me 50 ads of 300 words each, and it did it. And a couple were a little off, but most of them were really, really good. And I mean, that took me 5 minutes, and I was done, right? Like, I mean, that's the sort of thing, like if you can be the person that is more creative in the application of AI than the next person, then, in other words, you're using the power tools in ways that other people didn't think of, but they could have thought of, right? That will set you ahead of people. But how do you teach creativity? How do you learn creativity? I mean, it's difficult, right? So I think the most important thing is just keep playing with these tools and get really familiar with them. And then pursue what you're passionate about. Like, you know, if you're not passionate about computer science, don't do computer science, but I really think it's some computer science is valuable. I don't know if that answers your question, but yeah, okay, yeah.
This is a follow-up on his.
Yeah.
Because I think that was an awesome question. I am in like a very, very, very introductory computer science class right now. It's actually whipping my tail, but like
Okay.
one of the theory things that we've been studying a little bit is when there was kind of this boom of technology in the 1900s, a lot just more automation. A lot of people had a theory that it would actually lead to more jobs because they would need more people to run the technology, kind of like this prompt engineer idea.
Yeah.
But at least in the course, what they're teaching is it turns out is the exact opposite, that the technology was actually extremely efficient at running itself and a lot of jobs were lost.
Yeah.
Which way do you see it going with AI? Do you think there'll be more need for people to run it, or do you think eventually it's just going to do the exact same thing as earlier?
Okay, so there's an article on Medium, I think it is. It's called Robots Have Been About to Take Our Jobs for the Last 200 Years. And it shows, they have these like photographs of all these news articles going way, way, way back where it's like, oh my gosh, through all of this, you know, industrialization and automation, you know, we're going to lose all these jobs, and then it didn't happen, right? And then it happened again, and these articles kept coming out, and they just show article after article after article. And it hasn't ever happened before, so should we believe that it's going to happen in the future? Probably not. So what usually happens is people go from working more dangerous jobs that are more manual, that are more difficult, and they get to work jobs that are a little easier, more meaningful, not as dangerous, right? And that's kind of been the general transition over time. I think with AI, it's a little hard to sort of take that lesson from history and apply it to AI, but I think we can assume the similar thing will happen. Like, we're not going to lose jobs. Like I said, with creativity, the artists that refuse to use these tools, they're going to be outpaced by all the artists that do use them. So, you know, yeah, you can stay behind if you want, or you can get on the program and, you know, like, you know, get with it and start using these tools to become a better artist. You're not plagiarizing other artists' work. You're not cheating. You're using a power tool, right? So every job is that way. Like, there's going to be ways to apply AI in a lot of jobs, maybe not every job. If you're flipping burgers, you probably aren't going to find a way to use AI for flipping burgers, but maybe, because, you know, we'll have burger-making robots at some point. There's a couple of those already, but so I mean, I think it'll just be business as usual. We'll keep moving forward, but, you know, the important thing is you have to make a decision if you're going to keep up with these tools or not, because the ones that do are going to be the people that are successful. So I don't know what else to say about that, but yeah.
I just have a question. When I keep thinking about Jurassic Park when they're having that conversation on the table and the motivation for pursuing the discovery of where does intelligence come from.
Actually, hold on. I don't remember that scene. Can you describe it really quick?
It's when they finally visit the park and everybody, instead of being excited, is kind of worried.
Oh, yeah.
And then Malcolm comes in and says, we were so worried to discover if we could that we didn't stop thinking we should.
That's such a great line. Yeah.
And so what is the motivation, with the scientists that you see in the top of the world, what is the motivation for continuing to pursue discoveries in this area, or continuing to pursue the quantum realm? Where does intelligence come from? Is it based on human need, or just the desire to progress and to discover and to see what can happen?
That's such a great question. Thank you. Okay. I have so many thoughts on this. I mean, firstly, like, if you ask a hiker, why'd you climb that mountain? They'll say, because it was there. Like, we do things because they're there. Like, we have this opportunity. Why wouldn't we not pursue it? Especially when we could do some absolutely incredible things. Yes, it's going to be misused, and maybe we shouldn't for those reasons. But, you know, should we have not created the internet because it's the dark web is used by drug traffickers and pedophiles? You know, like, you know, there's a lot of evil in the dark corners of the internet, right? But the good that comes from the internet is so transcendent above all of that, that yes, absolutely, we should have created the internet, right? And I think with AI, you've got to look at it that way too. Like, yeah, it's going to be like this thing I mentioned where, you know, it's being used for these deep fakes, which at great harm to teens and probably a lot more things like that will happen in the future that we can't even envision right now, but that will become even commonplace. All those things are going to happen, and AI is going to keep changing the world because we'll be able to keep doing things we couldn't do before. I mean, I'm not an artist, but I'm creating an app right now, building a new type of social networking / dating app. And I needed art for I've got these different sections of the app, and I needed some like cover art for each section. And I just went to ChatGPT and to Midjourney, and I told it what I wanted to depict, and it spat out these beautiful illustrations that are now in my app. Right? It took me an hour to make 5 world-class illustrations, and I'm not an artist, right? So, I mean, I think this question of, that was the first part, is should we do it, even though we can, maybe we shouldn't. There was a second part of the question that I've forgotten.
What is the motivation that you're seeing in the circles right now that are pushing these boundaries forward?
Yeah, great question. So this thing here, Grok, Elon Musk delivered a speech where he talked about the dangers of AI, and like the next day he announces Grok, right? So, I mean, you know, there's a coalition of 100 of these like world famous researchers that all put together an open letter calling for a moratorium on AI research until the ethical concerns could be addressed. This is about 18 months ago. Elon Musk signed it, so did Sam Altman, probably, I don't remember if Larry Page signed it, but all these like bigwigs, like the billionaires, the AI luminaries, a lot of CEOs. I just think that's stupid. Because why would we slow down production of an AI, production of a technology that's changing the world? It doesn't make sense. Okay, we need to be worrying about ethical concerns, yes, but we can do that along the way. We don't have to stop. And anyway, if we stop, China will just keep going. Like, there's no point stopping this, right? It's coming whether we like it or not. What we have to figure out is how do we relate to it? How do we use it for good in our own environment? In as much as we're in a position of, like, I don't think you can regulate AI, but if you're in a position of, let's say you're running a university and all your students are using ChatGPT to just cheat and not even have to think about their assignments. Probably happens here. Anyone done that? I'm not going to ask. So if you're running a university, you might want to lay down some ground rules that people have to write their own essays, and they have to kind of prove that they've written them, or I don't even know how you do that. But I mean, there should be limits and so forth, but like you can't figure that. You can't do that by imposing regulation. It's never going to work, because what do I care if Biden signs off on something that says you can't work on AI until next year, until we figure out all the ethical concerns? I want to keep working on AI. I'm not going to listen to that. Who cares? So, I mean, basically, no one's going to listen to anyone that tries to control this. And especially the nefarious actors are not going to listen to any sort of control. So we should probably be encouraging the non-nefarious actors to build better tools to, for example, differentiate between what is real and what's fake, so we can catch these nefarious guys. And if we impose regulations, it's only the guys that are the good guys that will get stopped, not the bad guys. So, I don't know.
Kind of like the atom bomb.
Yeah.
Get there first and not at all.
So, yeah, there's a little bit of the mutually assured destruction stuff in there. That's,
Oppenheimer.
yeah, seriously. Who saw that, by the way, Oppenheimer? Yeah. I had a hard time with that movie. Mostly because it was all concerned about his affair and whether he had dealings with communists and all this. It didn't deal with the ethical concerns of this. And this gets back to your question earlier. Like, as an engineer who builds a technology, should you not have to care about the ethics of how your technology is used and what happens if it fails? Civil engineers, they are trained to think about, if I design a bridge and it collapses, am I guilty? They think about these things because ethics are part of their profession. I took computer science classes at 4 different universities, and not a single time did anyone even mention ethics. Now, I've heard that in some of the more recent computer science courses that ethics is a big part of that, and especially now that AI is a thing, there's a big AI ethics component. But AI ethics is very misguided, in my opinion. Like, we're worried about what happens if AI takes over the world. Like, what happens if machines become nefarious? They're not going to become nefarious if they can't think, if they can't feel, right? So, but they might make mistakes. So what we should be worried about, the true AI ethics are things like bias, right? Could even be, ethnic bias, gender bias, error rates. What happens if, okay, so Sebastian Thrun, who he was a Stanford professor. His team won the DARPA Grand Challenge and then the DARPA Urban Challenge, which was self-driving cars back in like 2001, 2, 3. They won these two things, and their team was acquired by Google, which started Waymo, which is Google's self-driving car solution, which is far ahead of any other self-driving car system. So he started that. He said to me one day, when I met him, he said, when you're driving a car, if you go like this, you kill your family. He's like, what sort of UI allows you to kill your family with one motion like that? That's stuck in my mind, because if a self-driving car does that, who's to blame? I mean, what Tesla will tell you is the driver's to blame, because they have sensors on the steering wheel. If you take your hands off for more than 5 seconds or whatever it is, then it'll beep at you and so forth. And it tells you when you start autopilot mode that you have to be alert at all times. But what Google found, so Google built this bubble car, right, which is this little thing. It didn't even have a steering wheel. And they're driving around Mountain View. I'd see them all the time. And this car didn't have a brake either. I think there's a big stop button that you could hit. And it would only go 25 miles an hour, so it was kind of limited. But Google found the reason why they took the steering wheel out of the bubble car is because the previous models, which were like a Lexus or something, they had a safety driver. And these safety drivers, which are low-paid employees, they knew their job was on the line if they didn't pay attention, because there were cameras watching them, right? There were sensors. Like, they knew if they weren't doing what they were paid to do, they would lose their job. Even these drivers, after sitting there in a self-driving car for 15, 20 minutes, the brain would start switching off because the car was doing the driving. So they would just they'd get on their phone, they'd just they'd fall asleep, whatever. Even though their job was on the line, there was not enough mental engagement for them to stay alert. So when you tell a person this car is going to drive for you, but you have to stay alert, that person's not going to be alert. So there's a guy, Joshua Brown, in Florida, who was driving a Tesla, and an articulated truck drove across the freeway in front. He hadn't looked at the car, out the thing. He was on his phone or something. The car went under the truck, and it took the whole top of the car off, killed the guy instantly. And the people that witnessed this, they said, this is about 8 years ago now. People that witnessed this, they said, the most horrifying part of this is that the Tesla kept driving at like 85 miles an hour for a mile and a half until the damage on one side of the car eventually took it off the street and crashed into a tree. So this is a sort of a detail. Decapitated guy in a car driven by an AI algorithm, and his car just keeps going. So I interviewed for the position, the head of the software division in Tesla Autopilot at one point. So I met with a lot of the most senior people at Tesla. And there's a guy, he came across from AMD, he was their main chip designer. He'd come across to Tesla because of this incident. Because what had happened after Joshua Brown died is Tesla was using a technology by a company called OpenEye, I think it was called. And OpenEye was just like an off-the-shelf solution for doing computer vision. And Tesla blamed that accident on OpenEye. OpenEye blamed it on Tesla. And so they parted ways, and so Tesla was going to have to design their own chips. And so they brought in this guy from AMD to design their own hardware from the ground up, right? So when I was meeting with him, I said to him, when this guy died, why did the car not detect a collision and try to pull over safely, at a minimum? They didn't even pull on the brakes. Like why Why don't you have a sensor that detects a collision and then pull on the brakes? And he said, oh, that's a really good idea. I'm going to have my guys look into that. I'm like, are you kidding me? You haven't even thought of this? Like, this is what you do. This is what your team does, and you didn't even think of this? And that's when I decided I'm not taking that job. I couldn't, in good faith, work on something with that much callousness, right, in the team. And, like, Elon Musk is using Tesla drivers as his guinea pigs with an unproven technology that is killing person after person after person. You don't even hear about most of these accidents now. That Joshua Brown incident, he's not the only one. There's multiple incidences where a Tesla went under an articulated truck. It happened again recently. There are multiple times when a Tesla, I've seen at least 3 or 4 of these next one in the news, in my own reading, and I don't go looking for this stuff, where Tesla crashes into the back of a parked fire truck. What could be more visible than a parked fire truck? It's like this solid red thing right in front of the view. And it just keeps going, like full speed ahead, and because the person's not paying attention, they get injured or killed. Another incident that happened with Tesla is this is in 101 North in San Francisco area. So there was a lane marker, so there was an exit lane, and the Tesla was going along, and it was locked onto the lane markers. And okay, here's the exit lane, and then there's a triangle of white lines that come to a point, right? And then there's a crash attenuation barrier here. So what happened is that the lane marker that went straight ahead had faded, so the Tesla locked onto the exit lane, the rightmost exit lane line, thinking it was the left lane marker of its lane. And so it started veering off, and it went straight into the crash attenuation barrier. And you can go read Tesla's statement about this incident. Every single time there's an incident, Tesla comes out with a statement. It says, we're not liable because the lane marker was faded, the crash attenuation barrier had been hit before, and if it had been fixed, the guy wouldn't have died. They gave 7 or 8 different reasons why they were not to blame. Like, they're enumerated in there. And my thought is, yeah, he wouldn't have died if autopilot didn't drive him into a solid object, right? Like, this sort of attitude bewilders me. And so, I'm sorry, I'm getting very passionate about this, but yeah, just last thought. So ethics matter, and again, to your point, like, we should be worrying about how these things are used, but it's not malicious intent on the part of AI that does these things. It's simply that AI feels the same about hitting a solid object as it does about driving down its lane, which is that it feels nothing, right? So we have to think about it in those terms, and what are the consequences? Because we would never go like this when we're driving because we know the consequences, and we have a certain way we feel about those consequences, right? But AI doesn't feel anything, and so, anyway, so.
Well, what's the difference between Google's Waymo and Tesla's technology?
What's the difference between a wristwatch and a supercomputer? I mean, I'm a little harsh. I'm talking mostly about Tesla's former generation. Their new stuff is pretty dang amazing. If you look at, so Andrej Karpathy is the one who took the job that I was applying for. When I walked away from it, he took it after that. This guy's amazing. He's a much better person for the role than I am. But he came from Stanford. He's one of the leading AI researchers. And he's given a few presentations at the, I think it was at the NVIDIA annual developers meeting, where he talked about the Tesla, how all the new autopilot stuff works. It's astounding. They've got so many enormous models doing all these different things, tracking all these things, and they've got all this complex way that it's all coordinated. It's really quite amazing. But this was all in an effort to rebuild from scratch with the new hardware that this guy, Jim, the guy from AMD, I've forgotten his last name. Anyway, the stuff that he built, and then they built a new software stack on top of that. So this is, I think, called Tech 3 or something. I lost track of their version numbers. But so the new stuff is amazing. But Waymo has been doing this. If you include the time that Sebastian Thrun was developing this at Stanford, Waymo's been working on this for 23 years. Tesla's been working on it for a few years, maybe 10, not even that, 7, 8, I don't know what it is. And this is another instance of hubris, right? So hubris There's this kind of like belief that you're untouchable, you're invincible, that what you do doesn't matter, and or you don't, there are no consequences will come to you. It's kind of this pride, and there's an enormous amount of hubris in Silicon Valley. When Uber started doing autonomous driving, within 6 months of starting, again, after like 15 years that Waymo had been doing it, and then Waymo still wasn't done. After 6 months of starting, Uber put their self-driving cars on the road in San Francisco. Within a week, they had rolled one of their SUVs on its side. They had hit a pedestrian on a bike. They'd gone through multiple red lights caught on camera by people observing them. I mean, this is hubris. This is what you see in Silicon Valley. You see a lot of this sort of thing. There's so much I could say about this, but I don't want to like bore you guys.
You're also recorded too.
Yes, I am. Is this going to be online?
Yeah, but we're not huge.
Okay, that's fine. Yeah, I mean, I'm just telling you the raw truth here. Like, no one will tell you this. But there's a lot of problems with how this stuff is being approached. And the problem is, you've got, last I checked, about 70 or 80 companies around the world developing self-driving car technology. They're all building their own stacks. They're not sharing much. There's a couple of open source things now that they might be sharing parts of. But everybody's building their own solution with their own set of bugs, their own set of idiosyncrasies. There's this, okay, so the same conversation with Sebastian Thrun, which now is like 14 years ago when I talked to him. I raised a question. So at this point, he was giving a talk, and I went up and talked to him afterwards, but he was giving this talk in front of all these people, and he was taking questions, and I raised my hand, and I said, have you considered what would happen as far as emergent behavior of these self-driving cars if they get in swarms? Like, because like if you get birds or fish, and they have very simple rules for how to move, but you put enough of them together and you get these very elaborate emergent phenomena, right? This is called flocking. Like you get these behaviors that emerge. I said to him, have you considered what would happen with emergent behaviors of self-driving cars if you get enough of them together? And everybody laughed except for him, because he had thought about it. But I think this is something most people hadn't thought about. And he gave actually a pretty good answer. But this video came out about a month ago from, where was it? It was like at some university in Texas or something. There was like this big game, and there's an autonomous vehicle test program around there that all these students had signed up for. They all called autonomous vehicles at the same time. And there were like 50 of them that all converged on this game. And they were in complete logjam. Like they were deadlocked. Like none of them could go anywhere. And all these students were walking around just like swearing at these cars, like, are you kidding me? This is what AI is capable of right now? So that's flocking behavior, that's emergent behavior. And there's just things that are like bigger than people are thinking about right now. And people are not worrying about these sorts of issues. So anyway, I haven't taken questions from here. Yeah?
At least with Tesla and Waymo, from my understanding, I think that Waymo is going on mapped roads, and Tesla is going on unmapped roads.
Yeah.
Is that true?
Yes, thanks. I forgot to finish the question here. Yeah, so there's a lot about, okay, so let's talk about what Tesla's approach is. Tesla's approach is and this all comes straight from Elon Musk. Tesla's approach is whatever a human does, a machine should be able to do. So since a human has 2 eyes and no radar, no LiDAR, no laser scanners, we should only need 2 cameras on a Tesla. Elon Musk, to his dying day, will defend this. Waymo has LiDAR scanners. Actually, my brother is building the next-gen LiDAR scanners. He works at Waymo right now. And so they have these like rotating lasers that spin and scan the scene. Waymo believes you need to be able to see, so Waymo would never crash into a parked fire truck because they see it there. It's like, it's right there. And they can see it in 3D, right? Mapping, though, is another big thing. And so Waymo, I'm trying to remember exactly because this has changed a little bit over time, but Waymo was always a hybrid between a mapped environment and a sensed environment because they believed you can't go one way or the other. Tesla originally was, they wouldn't map the positions of things like stop signs or anything like that. They had a basic like road map because you need to know where to turn and stuff. But they didn't map the physical obstacles in the thing. They said it should all be done by vision because that's what humans have, because this is Elon Musk's philosophy. So, some mixture of those two is important because you need to have the element of surprise. So if something is different from your expectation, that means something significant, and you should respond appropriately. So this is kind of Waymo's philosophy is look at what you expect to be there. If it's not there, then some surprise alert thing will come on and handle that case in a particular way. So here, this gets at like the fundamentals of what requires intelligence again, because if you're driving a car and suddenly there are cones that take you onto the other side of the road, right? So let's say there's 2 lanes in each direction. Your 2 lanes are closed, but then they divert you into 1 lane on the other side of the road, and the other lane is for oncoming traffic. And there's cones in between the lanes and everything. You may have never seen that scenario before, but when you see what's going on, you understand what's happening, and so I can violate this fundamental thing of not driving on the other side of the road in this one exceptional case because that's where the cones are taking me. So you do need both. You need both mapping and sensing.
Another question about just like the ethics with, I guess, driving in general, a thought I've had is if you have like a biker or a kid runs to the road and you're on like, let's say just like a single canyon road or something like that, and you either hit the person or drive off and possibly hurt yourself. So stuff like that, how do they go about with, I guess, ethical things as far as driving in that sense?
Yeah, so raise your hand if you know what the trolley problem is. Oh, wow. Nice. Your professors have done a good job. Okay. So this is a trolley problem, right? This is an instance of the trolley problem. If you want see something really funny, Google trolley problem memes, because people have taken the trolley problem and made all these like really esoteric versions of these sorts of trade-offs. But self-driving cars bring up the trolley problem all the time. Yeah, because, do you kill the pedestrian or do you kill the driver if you have to make that choice? And they polled people, actually, about this. And they said, if you were in a self-driving car, would you rather die than a pedestrian die, or would you rather the pedestrian die? And most people said they would rather that the pedestrian die, which is, I guess you could predict that would be the most common answer, but I don't know if I would answer that way, honestly. Yeah, I wouldn't answer that way at all. So, these problems do come up, but then how is an AI supposed to make that decision? You can either just maybe you have a setting in the console. It's like, kill the pedestrian if you have to. But otherwise, how is it going to make an actual ethical decision about that?
Also, how do they know the difference between like a child or like arcades, a deer or something like that? Because like there's, or different.
Also a great question. So so you might need to have something that recognizes objects. But then let's say, okay, here's a question. An empty plastic bag that's kind of got air in it or whatever, it's like, this sort of shape, it rolls across in front of you. A human can look at that and say, oh, that's just a plastic bag, I don't need to swerve, I'll just drive through it, right? But an autonomous driving system might think, that's a boulder, I need to swerve, and in swerving it might kill you, right? So you need these sorts of, the problem is when you drive, there's an infinitely long tail of contingencies that you've never seen before. Every time you get in front of the wheel, you're seeing something that's never been seen before in your history of driving or the history of probably all of humankind. There's always something different. And the problem is when you're in an open domain, when you have an open domain problem like driving, you need artificial general intelligence to solve that open domain problem in the general case. So AGI, artificial general intelligence, is when you have intelligence that matches human intelligence or surpasses it. So, I'll come back to your question in a second. But so the way to solve this is you try to limit the domain of what you're doing. If you want self-driving cars to actually be useful and completely safe, you have to block off a 10 by 10 block area of the center of the city, not allow manual vehicles in there, not allow bikes, have pedestrian bridges and fences so pedestrians can't go jaywalking. In that environment, when every car is autonomous, they can all communicate. You'll never have any accidents. But once you introduce these kind of general things like hitting a deer is probably going to kill you anyway, so you should probably avoid the deer. That's quite an easy decision to make. But what if it's a person? You won't necessarily die if you hit the person, but they might die. They probably will die. That's a much more difficult thing. And yes, you probably need object detectors to be able to make those sorts of decisions. So, go ahead.
I think you answered it. It's just about like the frame problem, like what to do, like solve it.
The frame problem?
Yeah, because I feel like that's kind of what you were addressing, right?
Probably, but define the frame problem for me.
It's like when there's so much information, like how do you code that into like a machine?
Right. Absolutely, yeah. So, yeah. Do you have more you want to ask about that?
Well, do you have like is there a more in-depth like analysis of how you think you could solve that problem?
Yeah, so the frame problem occurs even in natural language processing. If you, so frames in NLP are things like kind of the verb, the action that takes place. You have things that are acted upon and things that act, and this frame is kind of what happens and the state transitions that come out of it. Is that the same type of, is that relevant, is that a different type of frame?
What's basically like what variables are actually necessary to make like a correct assessment of the situation?
Right. Yeah. No, that's a great question. I mean, part of the problem is the way that we humans approach problems out in the real world is we don't have a fixed set of slots for frame parameters. We might be in a new situation where we have to add a bunch of parameters that we never considered before, and we were somehow able to take this new problem structure and derive something sensical out of it and then come up with an action according to our beliefs and our principles, right? One of the problems with AI is the frame slots are kind of fixed. It's like, okay, here's my feature detector. Is it a cow? Is it a sheep? Is it a human, right? We've got these things can trigger, these will fit in the frame parameter of what is this object. But then what if it's foggy and you've never seen fog before? How does that change all your parameters? There's a whole new parameter in here that you didn't anticipate, right? Like your lasers don't go very far through fog, and so suddenly, okay, you don't have your lasers anymore. How do you drive in a degraded state with other sensors, right? That sort of adaptation is, in the general case, impossible for AI right now. You have to kind of manually program these things in. If you guys have used Siri or Alexa or Google Assistant or anything of those, you'll get frustrated. I mean, I only use mine to ask what the time is right now with the weather because like it can't really do much more than that. I mean, I can say to it, okay, I can say, when's my next appointment? And I can say, when is my trip to Denver? And it will come back and it'll say, you're flying to Denver on Saturday morning at 7 a.m. Okay, so what's the weather going to be like when I get there? And it'll say, it won't be able to answer that question. And I can say, what's the weather going to be like in Denver on Saturday morning? And it will tell me, right? It couldn't make that single step of logic to go from a calendar plan to a location and then a location to weather. I have to bridge that gap. And this is the fundamental problem with frames and with intelligence, AI in general, is these steps, you can only go about one step. You see the same in ChatGPT. It can go like one step. You try and do some more complex logic and it will just fail, it will produce gibberish, right? It'll do one step, maybe two of logic, and that's all it can do. It kind of follows something through to the natural conclusion. So, yeah, I don't know if that answers your question, but.
Yeah, I think it did.
Okay.
I was also wondering if you could create a machine that would learn. Do you think that would help solve this kind of issue? Like if it could code itself well it would.
Okay, so let's get to some more really deep computer science. This is a great question. So in computer science, there's something called computability theory. And computability theory says that there's some problems that computers, Turing machines, can solve, and there are other problems that computers or Turing machines cannot solve, that will never be able to solve. The simplest example of this is the stopping problem, the halting problem. So the halting problem says, I challenge you to write a function that is able to read the source code of another function and say either this function will run forever or this function will stop at some point. And so that's the challenge. you might think you've written something that, like, you have this really advanced compiler, like parser technology that's able to read it, and you reason through all the logic of how this program is going to execute, et cetera. You might think that you've produced a solution to this problem. So you have a program that can tell you if another program is going to stop or not. But if you run that program on itself, and based on its output, you do one of two things. If the program says, so you got the program, you got the tester program that you wrote, and you got a program you're testing it on, right? So if the program you're testing it on halts at some point in the future, then your tester program, you tack a little bit on the end that says, then go into an infinite loop and never halt. And if the program you're analyzing never halts and will run forever, and you can determine that in finite time, then your program, in response to detecting that a program will get stuck in an infinite loop, your program halts and says this program will get stuck in an infinite loop. So it does the opposite of what it's analyzing, right? Now run that program on itself, what does it do? If it halts, it doesn't halt. If it doesn't halt, it halts. You have a contradiction, which means if you have a logical contradiction, that means the fundamental assumption, which is that you can build such a program, is flawed. So there are some things you can't build. You cannot build a program that will tell you if another program will ever halt. It's impossible. That should blow your mind. It blows my mind. And I've been thinking about this for many, many years. It blows my mind. You cannot write this program, ever. This is computability. So the problem is, in order to come up with a program that can write the logic for AI in an arbitrary scenario to build the logic to do the right sort of thing, you have to write a program which, oh, I forgot one part, actually, I forgot one step of logic before I go there. So along with the halting problem, there's another problem called program equivalence, which says, if you take program A and program B, then can you write a program that will check if program A and program B do the same thing? It's the same as the halting problem, it's just a little taking it back a step and like up a step. So program equivalence is also uncomputable. You cannot ever write a program that, in the general case, will take two programs and tell you if they produce the same output, if they do the same things in all the same scenarios. Then if they're exactly the same, yes, in a limited case, you can say, okay, those two source code files are exactly the same, so clearly they're the same program. But you can write the same program in many different ways, and if it's impossible to write a program that does that. So for AI, I forget who asked the question. Was it you? Oh, it was you, okay. So it's a really great question, because for AI to be able to write a program like a human can do, where you're driving down the street, suddenly there's cones. I've never seen this before, but I know that, okay, I'm going to violate this thing of driving on the other side of the road. I'm going to go over there. You're coming up with a program in your head about what you're going to do. To write an arbitrary program in an open domain, to your point, that solves a problem you've never seen before, you're trying to solve the equivalence problem, the program equivalence problem, because you can't write a program to do a specific thing if you can't even compare programs for equivalence. That's uncomputable. It's another reason why I think intelligence is bigger than Turing equivalence, because of this problem exactly. And I've never seen this anywhere else. You're hearing it for the first time, because I've never said this anywhere else either. But I've got some notes for a book that I'm calling The AI Myth, and this is one of the key points in there. I haven't written it yet, but. So yeah, this is really, really deep stuff. Like, this is at the very core, the lowest level of computer science, but it spans all the way up to the highest level of intelligence. Is like, are these things even possible? And again, this is why I think that intelligence is doing something bigger, grander than computation. Okay.
So I have a question. It's less philosophical and more applied. You talked about AI being a super tool,
Mm-hmm.
and that in order to stay ahead of the curve, you need to be creative in how you're using it.
Yeah.
What are some of the most creative uses that you've seen people use AI for?
Oh, man. There's one that I just came across the other day. It was so good. I can't think of what it was right now. Hold on a second. Maybe it'll come to me. Well, one that I heard somebody say recently is the job applications. They fed in job descriptions for 20 jobs they wanted to apply for and said, write me letters for each of these based on my background, my resume. Perfect, done. Like, why waste your time on that? I mean, seriously. That, I think, is a really good use of AI because, I mean, you're not cheating. right? You're not cheating. You're just using a power tool. I don't support using AI for cheating. I do support it for that sort of use because you're not being tested on this. You're not being graded. You just need it done. You just need that letter written, and you want to submit it. And you don't want to spend 6 hours writing 20 letters for 20 different jobs with all the different things and getting it polished and proofreading it and sending it to your friends to check and everything. Just use ChatGPT. That might be one of the best things I've seen, actually, is like cover letters and things like that. Because a cover letter, like, it's a waste of time for the person writing it. It's a waste of time for the person reading it. But it's got to be there, so use ChatGPT. But I mean, some of the, I think some of the best uses, honestly, are in art. I mean, I have my lock screen. You probably can't even see this. My lock screen on my phone. This is art generated by Midjourney. I just described this scene, and it produced this incredible. It's going to fade. There we go. This incredible cartoon of this man and this woman standing there, and they have these beautiful artistic flourishes. I described the whole thing. It popped it out in 30 seconds. Now I have a really cool lock screen. So I mean, those. I don't know. Like I said, I'm not an artist, but like this is one of the most beautiful things certainly I've ever produced. And it's inspiring. Once you start producing this sort of stuff, I've produced hundreds of images on Midjourney for all sorts of different purposes. And I feel like an artist now. I'm not, but I mean, so again, it doesn't impede creativity. It doesn't steal from creativity. It inspires creativity. It's an idea generator. So if you start thinking of AI in terms of being an idea generator, then I think that will give you some ideas. I want to pause here because we're running really late here. So you guys can, we've got a question. You guys can leave at any point. We can stop now, and anyone that wants to stay, we can keep talking. But let's take, where's the final question?
Oh, I was just going to say our parking tickets can expire, so we have to go.
Okay.
But I wanted to say
Oh, so is mine, actually. Yeah, no, you're welcome. You're welcome. So I'll take one more question, then we'll stop, and anyone who wants to stay longer and ask some more questions.
Thank you so much.
Yeah, you're welcome. You're welcome. And you guys, by the way, you can reach out to me on LinkedIn. Luke Hutchison, it's on the flyer. I think they even sent the link to me on LinkedIn. Just add me on there. You can send me messages if you got more questions or whatever. So, yeah. Any last question before we stop? Yes.
On your LinkedIn, it said you went to North Korea. I was curious about that.
Twice.
Really?
Twice. Yes.
No way.
Oh gosh. I could talk about this for hours too. So yeah, thanks. Thanks for the great questions. So yeah, I've been to, maybe this should be off the record.
Actually, I really want to. People that watch this will always wonder.
Okay, we'll leave it. It's fine.